Okay, this is kind of a test of my drawing skill, but I'm going to try to do this with adequate clarity. All right, let me try to explain what's going on here. That's G. Pardon me. A completely different concept in mind here. This is a situation where you look on your sheet and you see a diagram and you draw a different one. All right, now let's just make sure we're all on the same page here. So I'll walk you through this. I'm going to give you the answer first and tell you what it means, and then ask you to use it. Okay, here we go. Now let me see if I can get this straight. How about it, Larry, up there? You read that? Yep. Very good. Okay, just to be clear, this reads b squared plus c squared minus ab minus ac minus ab, c squared plus a squared minus bc minus ac minus bc, a squared plus b squared. All right, now what are we talking about? The situation is, what this diagram is intending to depict is kind of situation you start with. You have, just like we did over there, you got an object, maybe it's a regular geometric shape, maybe it's irregular. Regardless, you have chosen the center of mass as the center of your body coordinate system, and you've done a calculation either from a table or SolidWorks. You've figured out what the moment of inertia of that object is for its center of mass and a choice of body coordinate systems. That's this and this. Then along comes somebody and like a problem and says, that's great, I don't want that one. I want a different one. I want the moment of inertia of that object, not about its center of mass, but about a different point B, which is distant from the others by a distance A and B and C in the three directions, respectively. The axes of both are parallel. If they're not parallel, can't play this game. All right? Notice this is the analog of the previous. You were told the parallel axis theorem, singular. This is the parallel axes theorem. There are three here. Okay? And this is the formula. You simply take the moment of inertia about the center of mass, the one you got, and you multiply the mass of the entire object, big M, times this formula right here. Clear enough? And you get the new moment of inertia. Fair enough? Okay, very good. So let's, you guys are pros now, so let's do a, hang on. Let's do a quick little problem here. All right. How about it, Beckett? You were, I bet you were the slender rod moment of inertia czar, as I recall. Yeah. So this is as simple as I can make it. Okay. Oh, I'm not going to point to anything. So what I'd like to know is what is the slender rod's moment of inertia matrix about its end?
So it would be.
And I'm perfectly happy to act as your scribe if you'll just tell me what to do, or just think out loud.
Okay, so make a three-dimensional or three by three matrix.
Yeah, 3 by 3 matrix, very good.
And in the first column, first row.
Oh, okay, hang on, I'm trying to keep up here. You're already ahead of me. Yeah, maybe if you're going to use this, maybe I'm going to need a couple. Oh. And that makes, oh, I see what you were going to do. You were going to just go straight for the answer.
Yeah.
Make it easy on yourself here. Yeah. Yeah, make it easy on yourself here.
The first one is exactly the same as IG.
Exactly, it is IG, okay? So that is, over there, that's 1/12 mL squared. Right?
Right. And then in the matrix with the M.
Yes, this is kind of the tricky part.
So.
Anybody want to help Beckett out here? How about Isabella?
In the, I guess the IXX position, it would just be L/2 squared.
Oh, very good, very good. Hang on a second, Isabella's just ripping this right off here. Says in that position is L/2 squared.
Well, so it's because it's shifted up by L/2.
Ooh, very good. Okay, so what Isabella's basically saying that value there is L/2, right?
And then the YY term would be L/2 squared as well.
Okay, where are we here?
Everything else would be 0.
And everything else is 0? That's pretty radical. Where'd all the other zeros come from? You're basically, how about those 3 numbers, A, B, and C? How many are non-zero?
C is the only one that's not.
Yeah, C is the only one that's not. Okay, so this is good. You got a non-zero number here, you got a non-zero number here, everything else is 0. Fair enough? And sure enough, that's what comes out the other side. Okay, and that is it. That is exactly right. Good job, you guys. And that's the end of that video segment. All right. Yo, where are we? Yes, ma'am. Emma.
It's supposed to be IB, not I, not.
Hey, you're absolutely right. Thank you. That's exactly right. Did I do anything else there? Yeah. Okay, thank you.